Hey guys, video 2 for graphing linear inequalities. Now we are going to look how it will possibly look at your homework. First one says graph negative 2x plus 5y when it's greater than or equal to negative 15. So step one with these problems, just like when we graph linear equations, is to get it in slope-intercept form. We have to get that y alone. I have to isolate that y variable. So first I have the 5y term. I need to get that term by itself. So I'm going to add 2x to both sides. Add 2x, because the goal of this is to get that term all by itself. So I'm left with 5y is greater than or equal to 2x minus 15. So now that I have the y term alone, I have to get the actual y alone. So I'm going to divide by the 5 that's next to it, divide by 5 here, divide by 5, divide by 5, and I'm left with y is greater than or equal to 2/5 x. And 15 divided by 5 is 3, so minus 3. So now that I have it in slope-intercept form, I can graph it. So my y-intercept is negative 3, so we can dot at negative 3. And I'm going to rise up 2, run over 5, 1, 2, 1, 2, 3, 4, 5. And before I draw my line, if you remember from the last video, my step is I have to look at my inequality sign. And because it has that line there, that tells me because it has that equal to sign there, that tells me that my line has to be a solid line. So I'm going to connect these two dots, down 2 over 5, make one more to make sure I'm straight. Yep. And connect those. So there is the line portion of the inequality. And now I need a shade, and because it's greater than, if it's greater, I shade above. If it's less than, I shade below. I would shade up here. So that would be the solution to the inequality to negative 2x plus 5y is greater than or equal to negative 15. We're moved to number 3 because we can reach it. I have x plus 2y is less than or equal to 4. So first step is to get that y term alone. So I am going to subtract x from both sides, subtract x, so those cancel out. I'm left with 2y is less than or equal to negative x plus 4. Now that I have my y term alone, I have to get the actual y alone, so I'm dividing both sides by 2. Those two cancel out, and I am going to be left with y is less than or equal to, and that's negative x, that's the same as negative 1x, which would be the same as negative 1/2 x, and 4 divided by 2 would be a positive 2. Hopefully you can see that. Yeah, you can see that. So now it is time for me to graph that. My y-intercept is at positive 2, so we go up 1, 2. And then I'm going to rise up 1 and then run left the 2 because my slope is negative, so up 1, left 2. I'm going to do this a few times to help my line be straighter. Down 1, right 2, down 1, right 2. And then I still have the equal to sign in my inequality, so that means I'm going to have a solid line. So I'll connect my dots like this right here. But different than this one over here, I have a less than sign, so I'm going to shade below. Just like that. So that is the solution to x plus 2y is less than 4. We rewrote it in slope-intercept form, so it is y is less than or equal to negative 1/2 x plus 2. And I graphed it right there. Double check, positive slope going upwards, negative slope going downwards, and I have a equal to sign on both my inequalities, so both my lines should be shaded, and this is greater, so it's above, that's less than, so it's below. Okay, so there's those two examples. I'm going to scroll down a little bit to get to my other two, possibly. There we go. And on our bottom left one, number 2 says graph 6x plus 3y is greater than or equal to negative 15. So just like the last problem, our first step is to get it in slope-intercept form. So I need to get this y term alone. So I'm subtract 6x on both sides, subtract 6x, subtract 6x. Those cancel out. That leaves me with 3y is greater than negative 6x minus 15. I'm then going to divide both sides by 3, so I can isolate that y variable. Divide by 3, divided by 3, divided by 3, and that will leave me with a positive y is greater than negative 2x minus 5. A negative divided by a positive is negative. A negative divided by a positive is a negative. So that is my equation. I need a graph right there. So it's going to have a y-intercept of negative 5. So I'm going to make a dot down at negative 5. I'm going to rise up 2 and 1 to the left. Up 2, 1 to the left. Up 2, 1 to the left. I like to do it a few times just to give my line more guidance. But now we need to be careful when we graph our lines, because since this is an inequality and there is no equal to sign, that means the actual line is not part of my solution. So I need to make sure that when I graph my line that it is a dashed line. So I'm going to kind of just dash my line right here. Just like that. And because it is greater than, I'm going to shade above my line. So it's going to be shaded in right here. So that is the linear inequality graph solution to 6x plus 3y is greater than negative 15. Let's go over to number 4. It says that the graph 2 times the quantity of 3x minus y is greater than negative 2. So the first thing I am going to do here is to distribute that 2 to what's inside my parentheses. And we're left with 6x minus 2y is greater than negative 2. My x's looks like my y. There we go. There we go. Now I need to get that y term alone. So I am going to subtract 6x from both sides. Subtract 6x, subtract 6x. Those cancel out. So I'm left with negative 2y is greater than negative 6x minus 2. Negative 2y is greater than negative 6x minus 2. I am going to, this next part's important, move it back up here. I'm going to rewrite what I have right there. Negative 2y is greater than negative 6x minus 2. Okay, so this is where I bet we know what to do, but I want to remind us. This says that to solve for a y, we would have to divide both sides by a negative 2. Negative 2, negative 2. So negative 2 divided by negative 2 is y. Negative 6 divided by negative 2 is 3x. Negative 2 divided by negative 2 is a positive 1. So I'm left with y, 3x, positive 1. But here's where the kicker comes in. When we graph inequalities on a number line, or when we solve multi-step inequalities, or we solve two-step inequalities, we had a rule that to keep the statement true, to keep the inequality true, that when we either multiply both sides or divide both sides by a negative number, we had to flip the inequality sign, and that's true with this here too. So if I'm dividing both sides by a negative 2, that means I have to flip my greater than sign into a less than sign. So there is my equation right there. Y is less than 3x plus 1. So I am going to make a dot on the y-intercept at positive 1. I'm going to rise up 3 to 1 to the right. Do that a couple times. And there is no equal to sign. So I am going to draw a dashed line. I messed up there. I can't count. Up 1, 2, 3 over 1. Down 1, 2, 3 over 1. 1, 2, 3, 1. There we go. That looks better. I'm going to draw a dashed line. And then because it's less than, I'm going to shade it below it. Just like that. So that is the graph to the inequality of y is less than 3x plus 1. Hopefully these two videos made some sense. Please complete your assignments. I think you guys will watch these videos for a couple days. So complete your Monday assignment, complete your Tuesday assignment. That would be the bell to go to your guys' A period. You'd be going to A period. But complete your assignments. If you have any questions, email me, contact me, message me. But have a great day, Monday, Tuesday, whatever day it is, and I will talk to you guys soon. Bye.